Hello students, the question says two vectors u and v are such that they are given the vector u and the vector v, where q is any constant. So the first part of the question says that find the values of q for which u and v are perpendicular. So suppose if I have a vector a whose components are a1, a2 and a3, it's a three-dimensional vector, and if I have a vector b whose components are b1, b2 and b3, and if I have to prove that these two vectors are perpendicular, so the condition for that is the dot product between two vectors, that is a dot b, which is given as I'll multiply the first component of both the vectors, that is a1 into b1, plus the second component of both the vectors a2 into b2, plus, and the final component or even the z component of both the vectors, which is a3 into b3, that should be equal to 0. Now this is the condition for any two vectors to be perpendicular. That means the dot product between the two vectors should be equal to 0. So in this case, I'll write my vector u as q, 2 and 6, and my vector v as 8 into q minus 1 and q square minus 7. So I'll first make the dot product of both the vectors, which is u dot v, that is equals to, according to the formula, it should be 8q, plus I'll multiply 2 with q minus 1, so I'll get 2q minus 2, plus I'll multiply 6 with q square minus 7, so I'll get 6q square minus 42, that should be equal to 0. So if I solve this equation, I'll get 6q square plus 10q minus 44 should be equal to 0. So if I take 2 common from here, so I'll get 3q square plus 5q minus 22 should be equal to 0. So 22 into 3 is 66. So if I make a middle term of this, so I'll get 3q square plus 11q minus 6q minus 22 should be equal to 0. So from these two, I can take q common. So I'll be left out with 3q plus 11. From these two, I'll take minus 2 common. So I'll be left out with 3q plus 11. So the middle term of this is q minus 2 into 3q plus 11, and that should be equal to 0 because they have said that u and v are perpendicular. So if I put individually equals to 0, so q equals to 2 or q equals to minus 11 by 3 will be my answer for this question. Thank you, students.